It's working. So hello everyone and welcome to this webinar offered by Discover the Universe. My name is Julie. I am the director of Discover the Universe. Welcome to everyone who's online with us right now. I see many familiar names, so thank you for coming back. And welcome if you are watching the recording. So for those of you who are live with us, there will be a recording. It will be sent to all registered participants. So if you have to leave, unfortunately, or miss part of it, no worries, you can always go back and watch the part you missed. But we are very happy to have you live for this webinar on the planet Mars, which is a very fascinating planet. Before I let our speaker, because I won't be the one presenting today, we have a guest speaker, and before we go to that, I will just tell you quickly about Discover the Universe if you are new to our programs. Okay, sorry, I just want to make sure everything's working. It's sometimes weird when we're live. So the program Discover the Universe is really meant to help you, teachers and educators, anyone who works in the school system or in informal education, such as science centers, youth groups, whatever. If you'd like more resources to teach astronomy, we're here to help. So we developed some resources. We have many that we're working on in the background right now. We offer some webinars like this one today on different topics. We do have workshops as well for teachers, and I'll tell you more in a minute. Most of what we do is free and online. And even though we're a Canadian program, we're reaching beyond the borders. So welcome to someone from Romania, which I saw earlier. So that's always fun to see that we're reaching outside of Canada as well. And we're doing everything in English and French. So a similar webinar about Mars was presented yesterday in French. If you are interested in French resources, we have some for you as well. This is a program supported and offered by the Dunlap Institute at the University of Toronto, and also supported by astrophysicists across the country, such as the Canadian Astronomical Society and the Center for Research in Astrophysics of Quebec. So we thank them for their support to make this program possible and keep everything free of charge for the participants. I just want to tell you quickly about our upcoming workshop. In November, we will have our online workshop for teachers level 1. This one is meant more for teachers around grade 6, depending on the province you're in, but really it could be useful for anyone starting to teach astronomy, starting to teach about space. We will cover concepts which are, like I said, more closely related to the curriculum in grade 6, usually in different provinces. But if you would like to learn more about, how we can observe, what we can observe in the sky, stars, constellations, phases of the moon, Earth, Moon, Sun system, so eclipses, phases of the moon, and a bit of about our place in the universe, solar system. These are all concepts we'll be talking about next month. It will be online in a sense that it's actually going to be pre-recorded videos you can watch on your own time, and I will have office hours where you can join me if you have questions. So this is free, it's online, you can go and register right now already. And if you don't know how to reach us, I'm guessing if you're here it's because you've registered for this webinar, but in case you got the link from someone else or the recording, this is our website. And if you actually email that address, it comes to me. We're also on social media. So feel free to reach out. My job and our team, actually, we're growing, we're now a team. It is to help you teach astronomy. So we're happy to help you with that. So today, I'm not going to be the one presenting. We actually have Charles Woodford, who's online with us right now. He's an astrophysicist from the University of Toronto, and he'll be the one talking to you about the planet Mars and why it's interesting. And there's so much content actually about it. So Charles, are you here?
I am here, but I can't start my video.
Oh no, we can't see you? Oh, hold on. I'm going to try if I can change your status. This is weird.
Okay, in the meantime, what I'm going to do, I'm going to share in the chat to everybody 2 sets of links. So the first link is to the slides themselves. We are going to be providing you with the PowerPoint version of these slides, but I actually made them on Google Slides. So if you want to go look at them on Google Slides or download them in a different format other than PowerPoint, you can definitely do that through Google. So that's open to you. They're also open for commenting. So if you see a particular slide in here or a section that you think could use some upgrading, or maybe you don't think it has enough information, or maybe you just want to say, hey, you know what, y'all did a good job on this one slide. I'm open to all of those things. And so you should be able to comment on them. And in addition, you can also make copies of the slides to keep on Google Slides and use with your students as you see fit. The second link, slides.app.goo, One is for you to interact with the webinar itself. So what we're hopefully going to do is, I'm also going to try and share my video. What we're hopefully going
sorry,
to do.
Charles, I just upgraded you. Yeah, there we go.
All right.
I made you co-host, so now it works. Perfect.
Perfect. So the second link is where you're going to be able to interact with the webinar. So if you have questions, still send them in Zoom as per usual with these webinars. Please send them in Zoom because Julie's going to be helping me pick which questions, especially if we get a big barrage. But I'm going to be asking you guys questions as if you were students. So this is hopefully going to give you an opportunity to see where you can ignite debate or ignite discussion with your students. And I want you to kind of put yourselves in that shoe. So we're going to try and do something a little interactive. I don't know how it's going to go. We're going to try our best. It's going to be great.
Actually, thanks a lot, Charles. I didn't get to tell you because we're trying to figure out the video, but thanks a lot for accepting to present this webinar and for trying new things. And just before I disappear completely in the background, those links will also be sent to you. Well, especially the link for the slides will be sent to you with the recording tomorrow. So if you end up losing it, don't worry, you'll have access to it again by email. So thanks a lot, and I'll be in the background.
Awesome, thanks. Okay, so now we can finally jump in and get started. We are going to be talking about Mars, the fascinating planet, today. And just a little bit of background about myself. I am a recent graduate of U of T. I recently graduated with my PhD in physics. I used to work at the Canadian Institute for Theoretical Astrophysics and kind of still finishing up my work there as well. I don't work on planets at all, ironically. Most of my work, all of my work, has been on black holes and numerical relativity. If anyone knows those keywords, that's totally cool. If you don't, it's okay too. But I do have a lot of experience talking about Mars with the Dunlap Institute and through Discover the Universe. So I'm really excited to tell you all these really rad things about our neighboring planet. Of course, thinking about learning about Mars, it's almost like, where do you start? Where do you start learning about a planet that we've been observing since, you know, the dawn of human consciousness, pretty much. So you could go from anywhere from historical relevance, cultural and pop culture, to where can you find it in the sky? And because my background is so rooted in the science and STEM and observing and missions part of it, we're going to be focusing on the next few, on these questions of what are the characteristics of Mars, and what do we teach in terms of STEM courses with Mars. I am going to tell you though, in case you are teaching a science course right now and you want to share some hot dates, hot tips on Mars. I know these dates have recently passed, but I still think it's cool to mention that October is kind of Mars month, at least this year, because we had our closest approach, our most recent closest approach on October 6th, and we were in opposition with Mars on October 13th. And oppositions happen once every 2 years or so, just from how our orbits are structured, our Earth's orbit and Mars's orbit. And what I mean by opposition is that Earth is between Mars and the sun. So this gives us a really good observing opportunity. So again, these dates have just passed, but this is kind of why we're focusing on Mars in October, is because we have a lot of really cool stuff to see in the night sky with Mars in October. So thinking about Mars and all the cool stuff we can talk about Mars with, let's break it down to some topics. So we're going to talk about how do we find Mars in the night sky. We're going to talk about the characteristics of Mars. So things like, what is it like on Mars? Are there Martians? Are there little gray men running around? Area 51, we're not going to go that deep. It's okay. We're going to talk about Martian probes and landers. So what if we sent to Mars, and what do those look like? What do they do? How do they do it? And so on and so forth. And we're going to then finish off with future missions to Mars. So can humans go to Mars, and what is that going to look like? And you might have noticed I'm using a couple of different colors already. I have laid this out in a legend, and of course, because you can edit these slides on your own Google or through the PowerPoint that we're going to send, you can change this, but you know, orange and red for Mars, the red planet. And what I've done here is said that red is important points. So if you were going to present these as a lesson or part of a unit, and you wanted your students to take notes or to remember things for multiple choice or for tests or assignments, those key points, or what I considered really key points about Mars, are in red. So you've got to remember that. If you don't remember the rest, it's okay. And orange would be questions. So maybe questions that your students are asking you, maybe questions that you're posing to your students to try and get them interacting. Anything like that is going to be in orange, and everything else in white is just good old information about Mars. All right, so that's a lot of information about like how we're going to structure this, but bear with me because it is so much information. We may not get to go into detail about everything in the slides, but again, because you have access to them, And the Google Slides are actually hyperdocs. They're linked and they have videos and stuff in them too. I'm hoping that even if we don't get to talk about it today, that you will be able to gain lots of information as you go through it at your leisure. So the first and foremost is finding Mars in the night sky. So we want to think about the when, the where, and the how to observe Mars for all ages. I want this to be friendly for no matter what grade you're teaching, or even if you're not teaching anything. Perhaps you are parents and you have kids that you want to get into astronomy. I actually saw, I think, the Knight family who are from Newfoundland. I'm doing a call out. I'm also from Newfoundland. Thank you for joining. I appreciate it. So I just want to say a little bit about Stellarium, and I have a feeling if you are registered for Discover the Universe, you've seen Stellarium before. You probably have used Stellarium before. If you haven't, I'm just going to take a quick detour out of Mars and look at Stellarium. So we're not going to go into a whole lot of information about how to use Stellarium right now. I'm just going to give you a quick overview of what this could look like. But we also have resources down at the end where you can watch our our Discover the Universe's introductory video on how to use Stellarium. So there's lots of stuff for you there too. So Stellarium is essentially a planetarium software. And this is in Toronto because I live in Toronto, and I found Mars right away. Mars is in my night sky. It'll bring you up to things about Wikipedia and so on. And what I think is particularly cool about Stellarium, there's lots of things cool about Stellarium, but I can scroll to Mars. I can zoom in really, really far. And you can see it's moving. That's because I haven't stopped time. I'm going to stop time. And I'm going to, oh no, thanks. I'm going to go right into Mars, right there. Look at this. Look at this beautiful, beautiful map we have of Mars. So even in things like Stellarium, which is a free web-based, I don't pay for anything for Stellarium. This is just free on the web. You can also get apps of Stellarium. This is already a really good tool to start with to figure out where Mars is in your night sky. Maybe in relation to the horizon, maybe in relation to a cardinal direction like north, south, east, and west, maybe in relation to something else you can see like the moon, if you have the moon up in your part of the world. But even once you're in Stellarium, you can do a lot of learning just from here by clicking and looking at Phobos and Deimos, which we're going to talk about too. Those are the moons of Mars. So all that stuff is there too, which is really, really rad. So you can also change your location and all that good stuff. So that's one way that you can find Mars really, really easily. Just by using Stellarium. I don't mean just. Stellarium is a really great tool to have. There are, of course, other questions though. So we talked about the when, where, and the how. So let's think about where. Where can you view Mars? Well, anywhere. You don't have to go to any specific place to view Mars. It might not always be visible in your part of the world at night, and that's okay. It will be visible in your part of the world at night sometime during the year. But you don't have to like specifically go anywhere for that. So you don't have to go to an observatory. You don't have to leave the city if you live in a city to go see it. Because Mars is one of our neighbors and it's very, very close to us, it's really, really bright in our night sky. You don't even need really a telescope or binoculars to see it. You can see it in places that are heavily light polluted, all that jazz. You don't have to go anywhere to see it. It might not be visible in your part of the world, but you can definitely see it anywhere. And the how, I've already alluded to this, because it is so bright, you can see it with your eyeballs, or what you might call the naked eye. I just say eyeballs because that's who I am. But you don't need binoculars or telescopes, anything really fancy. You don't have to purchase any special equipment. If you want to, or if you have these things available, I think you're going to get a much nicer view of Mars if you have binoculars or telescopes, but you don't need them. And lastly, when? Well, it just depends on when Mars is visible at your part of the world. And because I knew we were going to have people from, different parts of North America and Europe and beyond, I didn't give any specific dates or times when Mars was going to be up because I knew that it was going to be varied for everybody. What I can show you is a really rad photo of the Milky Way and Mars. So when you do look for Mars, it's either going to appear whitish, especially if you're in a light polluted area, but most of the time it's going to look a little red. And that's how you can definitely know that you're looking at the red planet, is because the light from it is usually tinged a little red, which is really, really cool. And you can also see that with the naked eye. So what I'm going to point you to in terms of finding Mars is all of these really excellent tools. So we already talked about Stellarium. I'm also going to point you to time and date. I'm going to go over there and point it out. You know what? I'm not going to go to the tab because we only have so much time. But there's lots of things like Sky Safari, Skyview, and Starwalk. I personally use Starwalk because it is free and I have it on my phone. But if you are a teacher and you want to, say, assign a project to your students to go out and observe something, So maybe stellarium's not the best thing to use because it has a lot of knobs and whistles. It has a lot of things that they can maybe get distracted by. Maybe you just need to have, you know, when is this planet going to rise and set in my area of the world? Or is it even visible right now? And I would really recommend going to timeanddate.com/astronomy. Those are hyperlinked on this slide. And if you have the Google Slides open, you can go to it immediately. But you're going to see something like this, especially if you have location turned on on your device. If you don't, you just search for whatever region you're in. Usually you'll have to say in nearest city. And it'll tell you when things rise, so that's the up arrow, and when things set, which is the down arrow. And so I took this, I did the snapshot a few days ago. So a few days ago in my area near Toronto, Mars rose at, you know, approximately 7 p.m. and it's set at approximately 7:30 a.m. So in my part of the world, Mars is visible overnight. What's also cool about this, it'll tell you how good the visibility is. Usually things like Mercury and Neptune and Uranus are not very visible, but things like Venus, Mars, Jupiter, and Saturn, if they're in your sky at the, like in this, at this time of the year, you should be able to see them, and really, really well. So this is a really good one if you just want your times and if I can see it information, but stellarium is really good if you want to get a little bit more detailed about it. So that's tools for finding Mars, and that's finding it in the night sky. So you don't need anything fancy, and it may or may not be visible where you are right now, but you can easily find out if it is visible. So that's all really good stuff. What we're going to jump into next is characteristics of Mars. So what I mean by characteristics of Mars is maybe when your kids or your students come to you with questions like, what is it like on Mars? Where is Mars in the solar system? Is Mars in the solar system, maybe if they're young enough? Can anything or does anything live on Mars? Maybe they watch a lot of Looney Tunes and they're like, hey, Marvin the Martian, is that person real? Has anything ever lived on Mars? So maybe they are old enough to know that Mars is not a great place to live right now. I'm probably not going to have a life on Mars right now. I'm going to talk about that a little bit more in detail in a minute. But maybe they have a question about, like, were there aliens on Mars? Was that ever a thing? Why is Mars considered the best place for a human colony is a big one. So thinking about missions to Mars in the future. And of course, what similarities and differences does Mars have with Earth? So these are just some sample questions I thought that this particular section of the talk could answer. But you know, your students are your students, your friends are your friends, your kids are your kids. They're going to have different questions. But hopefully the information that are contained in this next section will have at least get you on the way to answering those questions, or maybe give you the resources you need to find those answers. So let's think about Mars in the solar system. So we have our usual solar system here, and really starting at the beginning. Mars is Earth's neighbor. Mars is one of our neighboring planets. I think that's where we need to start. So Mars is a neighboring planet, and in particular, it's the outer neighboring planet. So it's a little further from the sun than Earth. And again, this red means an important point that your students really need to remember. It's the fourth planet from the sun. I think that's a really key piece of information. Some more detailed information that you could go into with maybe really interested people or students or higher level students is thinking about things like terrestrial planets. So Mars is the outermost terrestrial planet. And again, hyperlinks, these are hyperdocs, so you can go and explore these resources that I put in here too. Quickly, a terrestrial planet is essentially a rocky planet. So we have 4 inner planets, Mercury, Venus, Earth, and Mars, and all 4 of them are considered rocky planets, or terrestrial. Terra is like a rock. The 4 outer planets, yes, there's only 8 planets. The 4 outer planets are considered gas giants. And if you really wanted to be fancy, you could potentially even call Neptune and Uranus ice giants because they're really, really cold. In addition to being a terrestrial planet, Mars is just outside or on the outer edge, depending on the definition, of what we call the habitable zone. And the reason why I'm bringing this up is because it's going to come up in a minute. And it's going to come up a little bit later. So what I mean by the habitable zone is where in the solar system we would expect life to exist on the surface of a planet. Now, this is usually on a terrestrial planet. How would something live in a gas giant? I don't know. It's a little science fiction-y, but that's okay. So this particular image is a little optimistic for the habitable zone in our solar system. It's really a little bit thinner mostly around Earth. Mars is kind of outside of it. And this is really telling us where is the sweet spot for a planet to be so it's not too hot and not too cold to have liquid water. Again, using this maybe in something like a biology course, you could think about what does life need, or for life that we would recognize life as we know it would need. One of the key things is liquid water. So if the planet can't have liquid water, well, out of luck for aliens. So Mars is just on the outer side of that habitable zone. And optimistic views, it might be slightly inside of it. More realistic views or more conservative views on it, it's probably outside of it. It's a little too far away from the sun. But that's your short thing on the habitable zone. So this is where Mars is in the solar system. So this gives us an idea of not only is it a neighbor, it shares some features with Earth. It's also a rocky planet. And it's also very near or just outside, just inside this habitable zone. I also want to point out that you may have heard the habitable zone referred to as a Goldilocks zone for anyone who's read or knows of the tale Goldilocks and the Three Bears. And the idea being, the habitable zone tells you it's not too hot, it's not too cold, it's just right. Yeah, so like the porridge in the story. So what we're seeing here, talking about Mars and the solar system moving to Mars, is orbit and its moons. So this GIF is actually from the coinciding of the closest approach and the opposition of Mars that happened in 2017. But the mechanics and celestial dynamics that happen in this image is also really true for how Mars and Earth orbit around the sun together. So this is in particular showing how Mars in the sky became bigger and brighter as it got closest approach and opposition in 2017. I will definitely say that Mars will never be the same size as the moon in our sky. That would be the end times, I think. That'd be some pretty apocalyptic celestial mechanics happening there. So Mars can get really big in our sky as it gets closer to us in closest approach. So that's just what this is showing. Mars, as we've seen by looking at the solar system, Earth is the third planet, Mars is the fourth planet. Mars is a little bit further away from the sun than Earth is, about 1.5 times as far, in fact. And it moves a little bit slower, about 80% as fast as Earth. So this might be a good point to pause if you were going to give the same information to your students and say, okay, well, with this information that we have about Mars, we know it moves slower, we know it's further away. Why does it move slower? Why is Mars moving slower in its orbit than Earth is? So this is a good opportunity to use those, the slides.app.goo link to send some feedback on that. So I want you guys to interact with this. I want to see what you think. Why do you think Mars moves slower in its orbit? Because this could be a question from your student, or this could be something you ask your students to try and get them to think about what's happening in an orbit. Maybe some laws they've learned. Okay, I don't see anything popping up. I hope you're using the Google one and not the Zoom one, because I can't see the Zoom chat as I present. Okay, we'll try again another time. But essentially, these questions, I want you to interact with them. The answers for them should mostly be in the slide notes, fun fact, but I do want you to actively think about it too as we go through together, because I think these are interesting talking points. Okay. So this is a question that you could ask your students. The next thing I want to talk about is Mars does have moons. It has two really, really small moons. I kind of laugh every time I think about Mars's moons because they don't look like moons. not what you would expect, at least, thinking about other planets in the solar system. And mostly because we think they were originally asteroids. So these are Phobos and Deimos. So we saw these on Stellarium a couple of minutes ago. And I just really want to highlight the size. So I am going to be putting more emphasis on metric units than I am on imperial units, just because, DU is Canadian and I'm Canadian too, and I think that the imperial system is a little bit confusing. So we're going to stick with kilometers and Celsius. Sorry for anyone who is using imperial units. You're going to have to translate that back. But keep in mind here, 20 by 28 kilometers. So this is a 3D object, but it's saying the widest part of it, the biggest area part, is 20 by 28 kilometers, and Phobos is bigger than Deimos. So the bigger of the two moons is only 20 by 28 kilometers. My city is bigger than this moon. So bananas. And so because of their really, really small size and irregular shape, they were probably asteroids that got kicked out of the asteroid belt and that by Jupiter. Jupiter kicks everything out of the asteroid belt and got trapped in orbit around Mars. So that's what we think happened with those moons. So Mars does have 2 moons, even if they're tiny. Moving on to more characteristics about Mars, the temperature on Mars. So as you see in the graphic, I want to highlight actually that the temperatures that are given here in terms of the average temperatures are taken over, an entire year, so all the seasons, as well as over the entire surface and day and night cycle. So remember, even on Earth, the temperature at the equator at high noon is a lot higher than it is at nighttime at the poles, and the same thing is true for Mars. So this is not the temperature everywhere all the time. This is the temperature on average, but average temperatures can still tell us a lot about the characteristics of a planet. So overall, we see that Mars is colder than Earth on average. It definitely has some overlapping temperatures. It goes up to 30 degrees Celsius, but it is overall much colder. And so another question you could maybe ask your students is, okay, well, we learned about the Goldilocks zone, we learned about the habitable zone, we learned about liquid water on the surface of the planet, and how that relates to how far away a planet is from its star. Why would that make it colder? How does it relate to how far away it is from its star? I gave away the answer. I'm not good at this. Okay. So definitely if you want to put some ideas into the link that is presenting at the top here, so you're going to have to probably type it now or use it in the chat that we had before. I would definitely love to see those scrolling by. You can also upvote answers from other people, by the way, if you're not comfortable putting in your own response. I did want to point out a couple of things that can happen when we look at average temperatures. So, Earth's average temperature is 14 degrees Celsius. Water freezes at 0 degrees Celsius. But if, we had a planet whose average temperature was at about negative 21 degrees Celsius, the saltwater oceans would freeze. So let's say for the sake of argument, it's Earth. If Earth was at, on average, negative 21 degrees Celsius, the oceans would freeze. And, we see that sometimes during the winter, especially in Canada, we see ice sheets and whatnot, but the oceans themselves, like all of the ocean, would freeze if this was our average temperature or slightly lower. So that's pretty cold. That's pretty intense. And then if it was even colder than that, so at about negative 37 degrees Celsius, antifreeze freezes as an average temperature. So Mars on average is colder than even that. So even though it does have an overlapping temperature range, the fact that its average temperature is, negative 63 degrees Celsius tells us that this planet's surface is pretty cold overall. So thinking about its temperature, we can also then talk about the atmosphere. And this image is of Mars. The edge of the planet is visible as well as the atmosphere. So the atmosphere is tinted red here. Oh, I finally got a response, but it's a little too late, so I'm going to keep going. Thank you, Anonymous. So the Martian atmosphere is mostly carbon dioxide, and it's extremely thin. It's actually about 100 times thinner than the atmosphere on Earth. One of the main reasons that the atmosphere is really thin, at least right now, at least it's really thin right now, and it's actually losing atmosphere to space, is due to the size or the mass of Mars. So another question that you could ask your students would be, what does the mass of the planet have to do with the size of the atmosphere? Now, of course, this isn't a completely contained question. There are lots of things that contribute to how big or thin or compositions of atmospheres of planets, but the mass of a planet certainly does have an effect on whether an atmosphere sticks around or it gets lost to space. So this is another one that you can ask your students, especially if you're talking about things like layers of an atmosphere on Earth. This might be a good point to bring in. It's like, Mars's atmosphere is a little weird, so Earth is not by any means the template. One thing I think is really cool about Mars's atmosphere is it's hypothesized, and it's probably pretty likely, that the Martian atmosphere was much more significant in the past. So it was much more dense, maybe had a different composition, maybe not. It is theorized right now that what happened to the Martian atmosphere is it got blown off by a solar flare. So that's not something you necessarily need to teach your students. That's a whole other realm of really, well, of interesting physics. What's a solar flare and how do they happen? But during a more chaotic time in the sun's history, it's possible that a solar flare just interacted with Mars. So like kind of an ill-timed, coincide, like an ill coincidence, solar flare that just blew away most of the atmosphere on Mars, and it was never able to recover. A dark thought, considering Earth is closer to the sun. So we're more likely to get hit by something like that. But the sun's not in an active period, so we're okay. And especially if you have students who like graphics, this is a little GIF on what we can think about the atmosphere on Mars. So this gives you a little bit more information about the composition. Again, mostly carbon dioxide and really, really thin compared to what we see on Earth. Continuing with characteristics, you can then also think about the soil and geology of our planet Mars. So not surprisingly, terrestrial planets, they're going to have layers. But again, Earth is not a template. So we know really well what the inside of Earth looks like. We've had a really long time to take very detailed measurements and make and do experiments and make hypotheses and have them disproven or proved on what the interior of Earth looks like. That the fact that we have a rotating core that's mostly iron or whatever, like we've had a really long time to figure that out. But we don't have the ability to say that for sure on Mars, or for that matter, Venus or Mercury. We don't know what their interiors look like. And that's actually true for all the planets. Earth is the only one where we know the interior. So this is a model, what I've shown here. This is a model of what we think the interior of Mars could look like, maybe from the information that we have so far. But I put a big question mark over it because it's an active question. We don't know. So this could be another question for you to ask your students. Why would knowing the interior of planets be helpful? What would that tell us? So I'm going to give you a few seconds to maybe enter that on the Google Slides link. Why would we care about the interior of planets? Maybe specifically to Mars, maybe not specifically to any planet, just in general. Why would we care about what the interior looks like? To compare planets and how they formed. Can I upvote that? Yeah. Ooh, I can present it. Very good. I'm also learning here. To know, okay, so I'm going to hide this again. We're going to continue. But thank you, Anonymous. Everyone's anonymous, so I can't even thank you by name. But one of the big things that we like to know about the interior of planets is to know how they formed. And then if you can make a model, or you can say like there are similarities between the terrestrial planets, there are similarities between the gas giants, you can say how planets form as a theory. And then you can apply that to other star systems. So like exoplanets, for example, maybe learning more about them by studying the planets here in our solar system. So knowing how the planet formed actually can tell us a lot about how our solar system formed and how other planets form, which is really, really interesting. On top of that, it can also tell you a lot about the history of the planet. So it could tell you a little bit about what existed there before, maybe more about the temperature, maybe more about the atmosphere, maybe more about the chemical composition of things. All that's on the table. So the interiors of planets is a really big topic and a really key science goal for missions to Mars. What we can definitely say, though, about what we do know about Mars, not so much the interior but the surface, is that the Martian soil is really, really dusty, but it is cohesive, and that the red form is from oxidized iron. So you can essentially think of Mars like a rust ball, because oxidized iron is rust. So that's rad. And this is one of our up-close photos of the soil on Mars from the recent InSight lander. So if you ever wanted to know what, or you know what, no, sorry, this is from Curiosity, I believe. It's Curiosity or InSight. I should have linked the credits better. My apologies. But my point here, this is what Martian soil looks like, and that's cool that we have photos of dirt on another planet. I'm not going to talk about this a whole lot just because we are running out of time and we have a lot of other really cool things I wanted to get to. But Mars can have aurora. This opens up a whole thing about magnetic fields and about solar wind and about charged particles. So this might be a discussion better suited to high school students or general adult audiences and experts. Just because you need a little bit more physics background and a little bit more understanding of magnetic fields to really appreciate why this is incredible. But you have a nice graphic, so we have that going for us. Some major features on the surface of Mars. Um, Mars has a ton of features. It's not lack for cool things on the surface. It's like any other planet, including Earth. There's lots of things to look at. But there are two that I want to point out. The first one is Valles Marinas, which is what we see on this photo right now. It's a huge canyon that stretches about 4,000 kilometers. And actually, if you want to compare it to things on Earth, it's about 7 times larger in every direction, including length, height, and width than the Grand Canyon. If you were to put it on Earth, or it was on Earth, it would stretch from Los Angeles to the East Coast in the United States. It would stretch from Toronto to Vancouver in Canada. Um, I mean, like, you can see it on the planet. It's ridiculously large. Um, the other big thing I wanted to point out is Olympus Mons, which is the biggest volcano and also the biggest mountain in the solar system, ironically. It's 3 times bigger than Mount Everest. Um, and, you know, Everest being the tallest point on Earth. So in particular, what I wanted to say about this guy is that it is a shield volcano. So as it was erupting, it was the lava was solidifying and making it grow wider as well as taller. So this is a big reason why it's huge, meaning that it was probably spewing lava a lot in the distant past. And just to give you an idea of how big this thing is, you could, like, Arizona could not contain it. I don't know if you, for anyone who is familiar with the United States or is familiar with Arizona, Arizona is not one of the small states. It's pretty large. It would be bigger than the state of Arizona. So that's a whole thing. All right, moving on to life on Mars. So we're going to talk about the past, present, and future of life on Mars. Not necessarily in that order, but what I just wanted to show here as kind of like a joke is that there aren't any Martians, at least not really, but we do have a lot of Martians in our pop culture and in our media. So these are 3 characters that are all called the Martian. So you have Marvin the Martian from Looney Tunes, Martian Manhunter from Justice League Unlimited in this version, which is property of DC Comics, and of course, still from The Martian, which is that was a film that was released by 20th Century Fox. Excuse me for a second. Okay, so we're not really going to talk about Martians, but I wanted to highlight that we've had a fascination with Martians for a long time, and that fascination has not decreased by any means. So in terms of the present on Mars, it's kind of a wasteland. This is a photo from Curiosity, or, you know, a mosaic of the photos from Curiosity, showing you the barrenness of the Martian landscape right now, or at least in the Gale crater. So right now, there's no conclusive evidence for life on Mars today. So unless something really remarkable happens, there's nothing alive on Mars. Could something change with that? Might we need to go back and put a little tick on this video and say this information is now out of date? Maybe. But chances are there's nothing alive on Mars right now. There's no evidence for that. And so a question when you talk about life on Mars, or again, maybe not you, or if you are someone who teaches biology or you think it would be cool to talk about your space unit, maybe talk about astrobiology a little bit. What does life need? What would prevent it from existing on Mars? And then you can maybe it could be a research project, or maybe you could say to your kids, how many causes can you list? It could be a fun class discussion activity. And feel free to list them in the not the chat on Zoom, but the chat for Google, the slides.app.goo. What would prevent life from existing or evolving on Mars currently with what we know about it? We just talked about all the characteristics of Mars. Are any of those preventing life from existing or evolving on Mars now? Spoiler alert, yes. That being said, there is evidence for the building blocks of life on Mars. So a number of meteorites have fallen to Earth from Mars, and actually 126 of them. And was a recent upheaval in terms of what do those meteorites mean when some of them were revisited. So there was some analyses that said that the meteorites contained fossils of bacteria. There were some analyses that said that these meteorites contained evidence of organic chemistry happening on Mars. But the trick with meteorites from other planets or other things arriving on Earth is that they get damaged and they get contaminated by things on Earth. So anything from meteorites needs to be taken with a grain of salt and a bit of realism. But the evidence for building blocks of life has been confirmed by rovers on Mars, and those have not been contaminated. They have a much less likelihood of being contaminated like meteorites. So that looks pretty good. Also, War of the Worlds, okay. In terms of the past of life on Mars. So this is a illustration. The right-hand side is Mars as it is today. That's a real photo. And on the left is an illustration of what Mars could have looked like early in its life. So this was when the habitable zone in our solar system was a little bit bigger or a little bit wider. It might probably encompass Mars for sure. We really think that Mars had liquid water on its surface, maybe not as much as what's shown here, but also that it had a really substantial atmosphere. So those two things are really big for having life evolve, or life as we know it, life that would require liquid water that would be carbon-based. We know that liquid water existed thanks to all the information we have on the geology and topography of the landscape. So things like riverbeds and lake beds that we see on Mars now that could really only be formed by water. And that was one of the really big missions for Curiosity, in fact, which we're going to talk about in a second. Mars is also believed to have had a substantial atmosphere. Of course, this is what we're showing with clouds. But the only way to say for sure if Mars did have life in the distant past is to say, you know, here's a fossil of a microbe or a bacteria, and that would seal the deal. But until we have something like that, or that there's biosignature chemicals still in the soil or still in the atmosphere to some degree on Mars, we can't say for sure if there was ever life on Mars. We can say that it was probably likely, the conditions were favorable, but we need those fossils. Okay, and in terms of the future, I'm going to skip by this just for the sake of time. But the idea here is that Mars does have organic chemistry on it, but because of all the other challenges with the characteristics of Mars, it probably couldn't evolve life as it is right now. The next Martians will probably be people. That's the point. And that, you know, eventually the sun is going to turn to a red giant and move the habitable zone out. So maybe things will change on Mars. The solar system is not a constant. It does change. Okay, so a little bit later than I was hoping, but I wanted to stop and answer questions that might have been piling up in the chat and that sort of thing before we move on to Martian probes and landers. I'm only going to be able to give you a couple of minutes so that we can go through some of the stuff in the rest of the webinar. But Julie, any questions that you think I should answer?
Hold on. I see we had some comments. So some people did manage to put some directly in your slides app. I was also anonymous, was sometimes me.
Oh,
I was taking, not always, but sometimes I was taking the comments in the chat and putting them on the slides. But if you have specific comments for Charles at this point, either type them in the chat in Zoom or in the app. I see a few other things that arrived. I see a few. Oh, actually, hold on. There is a question in the app.
Yeah, this here in the app. I was just wanted to ask about Zoom first before I went back.
Okay. I don't think there was anything specific in Zoom at this point. Okay. I'll keep monitoring. So yeah, you can go ahead with the other ones. Oh, well, hold on. There's one that just arrived. Question about the methane on Mars. You skipped very quickly over that.
I did. Yeah, sorry.
No, but it's okay. It's I understand time is, but time is a factor here. I just realized I'm talking and you're not seeing me. Maybe that's better. Do you think, what do you think is the methane, the fact that there's methane in the atmosphere is pretty interesting. It could be biological, it could be geological. What's the latest take on it very quickly?
It's an active debate is what I'm going to say. So as from what I can tell, and again, I'm not someone who does research on Mars explicitly, and more specifically, I'm not someone who does research on astrobiology on Mars explicitly. So what I can tell as someone who is really involved with, you know, space and parsing this information is that it seems to be a debate in both directions. So there's not really a field, the field isn't leaning towards it being, yes, this is a biosignature, or no, it's not a biosignature. There's debates on both sides, and there's good evidence on both sides for both of those arguments. And what I can definitely say to that is that there are people who are experts in that area, especially at the 2 astrobiology institutes at NASA, which I've linked in the slides. So I definitely recommend checking out and see if they have any statements on that, or if they have any anything that you could look at for more updated information. But from my overview, it doesn't look like there's a leaning in the field one way or the other.
It's a fascinating topic. This is definitely something that future probes will be looking into. Go ahead, I think, with the questions in the app for now.
Yeah, so there's just a couple here. Some of them were answers to questions that I asked, so thank you for doing that. For George Drake, yes, it doesn't, you're correct. I'm going to present it. This is so fancy. Based on Earth extremophiles, life not ruled out on Mars. That's true. That's true. It's just really unlikely. You know, life can sometimes find a way. We don't know everything about life. We don't know exactly what to look for in all situations, but all we can say is like the probability. So probably there's no life on Mars, but there could be. Absolutely. We've seen life flourish in really extreme conditions here on Earth and also in space when we send especially water bears up in space. I can't remember their real names right now, but they're water bears. So you're right, but just considering things that are that in terms of probable, that's the idea. Oh, things are upvoted. Very good. And okay, scrolling back down. This is another question. If Earth has only bacteria and proteins, would that be sufficient to say life exists on Earth? Yeah, so life doesn't always look like trees and plants and animals and fish and reptiles and birds and stuff. It can look like it is defined as bacteria. So bacteria and microbes count as life. It doesn't have to be something like humanoid form for it to be life. So if Earth had only bacteria and proteins, if it was an alien civilization that was looking at us and they were like, hey, we see some chill folding proteins over there, then they would be like, yeah, that planet has life and it could evolve into something more interesting. Leave it alone for a few billion years and we'll see. But yeah, that's a really good point. So life doesn't always look like people or like dogs in particular. I don't know. Martian dogs, that sounds cool to me. Okay, moving along, because I also want to give you some time at the end to brainstorm about what you're going to do with this information. So we're going to fly through Martian probes and landers pretty quickly, but some questions from your students could be, how do we know things about Mars? How do things get there? What do they look like? What do they do? What are the future missions to Mars? All of that good stuff. So what I'm going to show you first is an overview, and this is showing you the landing sites of the rovers and landers that have been sent to Mars. Now, there's a number of missions to Mars in the past as well as in the future. So there's been a lot of landers, probes, satellites, flybys, the works. A question that you could ask your students, especially if they're just getting into spacecraft, is how are these things different? What's the difference between a probe and a satellite? What's the difference between a rover and a lander? You can answer that in the Google thing if you want. But that could be a good place to start to understand the terminology that's used in this field. Okay, so there are questions popping up in the Google thing. Keep in mind, questions in the Google thing are not ones that I can answer during the during the talk. Please send questions to Julie in Zoom. Okay. So more specifically about missions, however, there have been 45 completed missions and 49 of launch missions in total, which is really interesting. But when we think about things that are being sent to Mars, and this is not just for Mars, this also kind of applies to things that have been sent to other places in the solar system, especially to the moon and to our outer solar system. But the two most common causes of mission failure in general are launch failure and spacecraft failure. And this is also something that you can think about with your students. Why? Why would these be the two most common types of failure and what do they mean? So I'm going to answer this really quickly just because I think it's really interesting. Launch failure is when something goes wrong during launch. So this could be something that's ignited incorrectly. This could be a leak that's caused a problem. This could be a mechanical error. And then spacecraft failure would be when it gets to its destination, something fails to open, something fails to deploy. We lose communication, it loses power, something like that. So I think what's really interesting about that is like when we see mission failures, they're typically, overwhelmingly actually, either a failure during launch, so from the ground to Earth orbit, or they're a failure when they get to their destination. There are certainly cases where, spacecraft or missions fail in other areas because of different things. I'm not saying these are the only two things that happen, but I think it's really interesting to think about that, most of the time missions fail because of something we didn't do right, something that humans couldn't control or couldn't do right or didn't account for. So that's something to think about too. Okay, for the sake of time, I'm going to skip over a lot of this, but maybe look at this for a minute. So the very first probes that were successfully went to Mars and took photos were the Mariner 3 and 4 probes, and in particular, Mariner 3 had a launch failure, so it didn't make it. But these are identical. These are identical missions of robots. So these are the very first photos that were taken of Mars, or two of them in the set. And what was really cool about this is that they were able to confirm that there were craters on Mars. So these are up close craters on Mars that Mariner 4 was able to take. And this tells you a few things about, like, okay, well, if you see a lot of craters on the surface of a terrestrial planet, chances are it doesn't have an atmosphere that could burn them up, burn up meteorites rather, as they were coming in. So that's why we see a lot of craters on the moon. It doesn't have an atmosphere to burn things up as it goes in. Some other, these are just ones that I picked out. Of course, there's lots of missions to Mars, but other two that are really, really key are the Mars Exploration Rover Spirit and Opportunity. They were identical. I should have mentioned Mariner 3 and 4 were in the 60s. The Mars Exploration Rovers were sent in 2004, and they lasted a really long time. They were only supposed to be operational for about 3 months, 90 days. And Spirit was operational till 2010, and Opportunity was lost in 2018. I say lost because it's kind of a sad story. So it was the longest lived rover. It lasted about 15 years. It traveled about 45 kilometers, so it was the farthest traveled rover as well. And the only reason that its mission stopped was because it got stuck in a planet-wide sandstorm or dust storm. And because these rovers, all the rovers, are solar powered, it didn't have enough power to make it through, and it shut down and we lost communication. So always a little sad. But what these rovers did do in their time on Mars was that they confirmed that liquid water did exist on the surface. So these were key in that confirmation and that discovery, or that conclusion rather. And it had the right conditions to support microbial life even today, even though we have other challenges such as temperature and atmosphere and the lack of liquid water. But it told us a lot about Mars in that way. So this is one of the last panoramas, or the last panorama that Opportunity sent back. The reason why the coloring looks off is because it didn't have a chance to take this panorama in all of the color filters that it would have ordinarily. It only got to send back a few of the completed images. And this is its long look back. Again, it was the farthest traveled rover on Mars, and this is a look back at its legacy, which is pretty incredible. So these are some of the numbers for Opportunity and Spirit. But what I wanted to point out is the last transmission. So these words did not specifically come from Opportunity. This is kind of what the code, or what the data that was sent back right before it went offline said. But it's essentially, my battery is getting low, or my battery is low and it's getting dark. And if that doesn't tug at your heartstrings, I don't know what would. And then of course, being Canadian, you can't not talk about Curiosity, primarily because the Curiosity rover, or the Mars Science Laboratory rover, has the APXS, which is the alpha particle X-ray spectrometer, which essentially tells you the chemical composition and quantities in soil, which is the main point of Curiosity. It's there to tell you, or it's there to tell us about potentially microbial life, the geology of the Gale crater. It's there to say, was there life on Mars in the past? And all of those things need to know about your chemical composition of the soil samples. So looking at that, the APXS is on its little robotic arm that sticks out, and it puts it in soil samples to tell us that information. So the APXS was developed at the University of Guelph in Canada and made by MDA in Brampton. So Canadian connection. We're going to skip over InSight and Mars 2020, but essentially InSight is the most recent rover to successfully land on Mars. It landed in November of 2018, and the Perseverance rover is on its way. And it's one of the Mars 2020 rover in particular is one of the key steps before sending humans to Mars. This little GIF is InSight pushing a probe into the dirt. I just thought it was really, really cool that we had a video of a probe on Mars pushing its baby probe into the dirt. It's pretty cool. Last but not least, of course, future missions to Mars in the last few minutes. before we even talk about like future missions to Mars, there's already a ton of missions that are currently operational and en route. Um, so in particular, we have 6 missions that are en route and 8 that are currently operational. Um, most of these, however, are not landers or rovers. Most of these are orbiters, or satellites rather. And one question you could ask your students if you were going to get them to talk about, or you wanted to talk about spacecraft, is why do we send orbiters and satellites more frequently, or more of them, than we do landers and rovers? So there's a few things you can think about there. It could be the weight of the cargo, it could be the cost, but more importantly, it's going to be the likelihood of it succeeding. Leaving and entering atmospheres, even really thin ones like Mars, and landing anything at all that's been in space is tricky business and really risky. Chances are you're going to crash and burn, literally. So that's definitely a reason why mostly it's orbiter sent. But I think this is a good critical thinking check to ask students for sure. Oh, a quick question about why is the time different? I am going to answer this one because this is a really good question. Why is the time different, the time it took the Mars probes to get to Mars? Well, Mars and Earth don't orbit at the same speed, so they're not always the same distance apart. And it also depends on what the mission plan is. So if the mission plan is to go direct to Mars, timings are going to be different just because Earth is traveling faster than Mars is, and our distances are always growing and shrinking as we go around our orbits. So that's one thing. When you send them will depend, and how fast Mars is moving will depend on how long it's going to take to get there. The other thing could be the type of rocket that's used, the type of deployment system. Keep in mind that orbital insertion, so a satellite going into orbit, is going to be a lot faster than trying to land. So that could also be a factor for landers and rovers. And last but not least, oh wow, I totally forgot my point. I am so sorry. Oh yeah, sorry. The most important point is if its destination isn't necessarily Mars, or if it has another scientific goal beforehand, it might stop along the way and do something else. So for example, there could be a gravity assist from Venus on some of these probes. I don't know if that's necessarily the case. I didn't look into every single one of them, but that's why some of the times are different. What I do think is really cool about the en route ones is that all of them are going to arrive in February of 2021. So keep an eye out on February 2021. There's a lot of proposals for there as well. So there is a plan for crewed mission in 2024. I don't know how realistic that is. And that's why I had a big question here that you could have a discussion with your students, because this is really a big question too. It is sponsored by SpaceX, and they do have a plan to do this. They are technically on target for having the science part nailed down for this mission, but it is, I would be very surprised if this mission happened in 2024, let's put it that way. This is kind of what they plan to do. So the basics of going to Mars, you spend a lot of fuel getting out of Earth's orbit, or getting into Earth's orbit out of the atmosphere. So their plan would be get into the orbit, refuel, go to Mars, and then make more fuel. And it's because you want people to come back. That's the goal. You would want them to not have a one-way trip. But in particular, thinking about going to Mars, it is a 6-month journey one way. Humans have maximum been in space for about 13 months, and we know it has a really, really disastrous effect on the body. So having astronauts and cosmonauts in space for that long in zero gravity, not even just microgravity, but in zero gravity, and then on a planet that has a much smaller mass, it's unknown what's going to happen to them, and that's scary. So if you're interested in things like that, a show that did it really, really well, The Martian is a really good movie to watch if you're looking for things that are pop culture-y, as well as Away on Netflix. Away focuses a lot, at least right now, on the journey to Mars, which is, especially from the mental health perspective, is really important to consider. Okay. I don't have time to go through the resources with you right now, but I am going to point them out. If you want to learn more about the solar system, we have things for you as well. The Introduction to Stellarium, and in particular, Mars Trek. I really, really suggest checking out Mars Trek, even though I won't be able to go through that with you right now. It's essentially Google Earth for Mars. There is a Google Mars, but this is better. You can overlay layers such as the journey of curiosity or the journey of opportunity in particular. You can look at the elevation, you can look at the topography, you can look things on a map versus 3D globes. All kinds of cool stuff is on Mars Trek. Really, really suggest that, especially if you're going to assign any kind of projects for students. So these are kind of the takeaways from what we talked about today. If you only get 4 things out of this, Mars is our neighbor, 4th planet from the sun. It has changed a lot over its lifetime. It had liquid water, now it doesn't. It had an atmosphere, now it has a really thin atmosphere. It probably doesn't have life now. It might, but probably not. But it might have in the distant past, and we're looking for fossils to see if that was the case. And missions to Mars continue for a whole slew of really awesome scientific goals. So we are going to do questions now, but what I'm going to invite you to do while we do questions, if you have time to stay and do this, is to think about how you're going to incorporate Mars into your lesson plans, or how you might suggest space stuff to other teachers in your education institute or in your group. Because just remember, you don't have to be doing the space unit to talk about space. A lot of the topics we talked about today fall into Earth and space science. They fall into physics, chemistry, biology, general science, engineering, and so on and so forth. So you could be doing any one of these courses and just insert something cool about Mars. I believe in you. And with that, I'm going to hand it back to Julie.
Thanks a lot, Charles. Lots of great info. And I think maybe it might be overwhelming for some people watching, like there's so much info, but the good thing is that they have the PowerPoint and they can pick and choose what they want to use afterwards. That's the goal of it with these webinars. We give you a lot of information and then you can modify and use it as you want in your own classroom and adapt to the reality for your classroom and your students. So thanks a lot, Charles. Very interesting, great info. I'm just checking the chat. Right now we have a lot of thanks, not so much questions. I don't know if some of them arrived on the slide app, but yes, if you do have questions, this is the right time. Or if you'd like to discuss how you could use it with your students, always interesting to, for us anyway, it's very interesting to see how you could use this and incorporate it in your classrooms, and for you know, the exchange with others, sharing with other teachers as well. Hold on, we do have some things that are coming up. Hold on, this is moving too fast right now. Do you know, can you comment a bit on some dangers of humans going to Mars? You know, cosmic rays or radiation. You mentioned being in low gravity or zero gravity for a long time in terms of muscles and on the body, but can you comment on other things as well?
Yeah, so a lot of the things about the dangers of going to Mars are what we've talked about in terms of characteristics. So thinking about in terms of, say, like temperature. So it's usually pretty cold on Mars. So in terms of that, you need insulation. Mars doesn't have much of an atmosphere, so it's irradiated by the sun constantly. So you probably don't need something like as protective as a spacesuit that you would need to go on a spacewalk at the ISS, for example, but you would still need insulation from cosmic rays. You would need insulation from high UV. You would need insulation from, you know, all of those really nasty high energy rays from the sun just in general, as well as thermal protection so that you're not freezing. So just those two would require a spacesuit for sure. And then of course, because there's a lack of atmosphere and it's even what's there is not oxygen based or nitrogen based, you need to have air supply too. So those 3 are enough danger in and of itself. The danger with Mars being low mass is that, you know, a lot of all of our physiology is based on being on Earth. So if all of a sudden you go from being, you know, 200 pounds to, I can't remember what exactly you'd be on Mars, but you'd be like something like 120, 130, your muscles are going to deteriorate to a point. And we've already seen in microgravity people starting to lose their vision to a point. Not completely, we haven't had anyone go blind as far as I know, but your vision gets worse. You start having symptoms of type 2 diabetes, which is terrifying. The spine elongates. There's all kinds of things that could happen that unfortunately we just don't know. And I think that might be the scariest risk of all, is that we don't know. So you can account for some things, but you can't account for everything, especially when it comes to what's going to happen to the human physiology in a lower gravity environment. Even then, just considering what happens to the human body when it's in a zero gravity environment for long periods of time. Like, what is that 6-month journey going to do? And again, highly recommend Away. They go into a lot of the fears that come with that. It's really, really cool.
Definitely a show I have to watch now.
Yeah.
haven't tackled that one yet. We have lots of great questions coming up. I just want to highlight, if some of you have to leave, thanks a lot for joining us. And we'll be talking for a few more minutes. If you're okay with that, Charles, we do have a few good questions coming up.
Yeah, I'm okay staying.
Perfect. So, but for those of you who have to leave, thanks a lot for joining us. And if you're watching the recording, obviously you can watch a bit longer, but I just want to thank you for staying so far. This has been very interesting and lots of great questions coming up now. Hold on. Some questions about I think there were some recent announcements about underground lakes on Mars. And also a few years ago, those streaks that seem to be running water, maybe on the surface, maybe salty water or with perchlorates in it. So if you want to comment a bit on the water and the lakes and the recent discoveries.
Yeah, so this is where it's a little difficult. I am not an expert in water on Mars or like new observations on Mars. When I look at Mars information, I'm more so interested in the geology and seismology information from InSight. So I know that there have been observations that could be underground lakes and that could be flowing water. I would be absolutely shocked if there was flowing salt or fresh water on Mars. I think probably what they're seeing might be something else, if they're seeing something at all. Keep in mind, this is a planet where it's really far away, and unless something is happening with a rover, it's hard to say from photos alone. Like, you really need the probes and the landers and the rovers on the ground to confirm it. For the underground lakes and rivers, I think that's possible. And I think that actually raises a really interesting point on potentially life on Mars in particular, because we're already thinking about this kind of scenario on Enceladus, which is an ice moon around Saturn, which, it's so far out of it's so far out of the habitable zone that nothing could survive on the surface, but there's a liquid ocean underneath the ice sheet that's covering its outside. And that could certainly have life in it. And if there are pockets that are actually on Mars that are underground lakes, that could have life in it too. And that would be really, really rad. But I can't say for sure one way or the other, just because, like, again, I'm not on the science team for these investigations. And I think we need to be really, really careful when we look at news about our planets and from Mars and missions that are rolling things out, is that you want to be very careful that you're looking at from accurate scientific sources and not something that's been exaggerated by popular culture. I'm not saying that this has been exaggerated, but we just want to be careful, because claims like this can certainly be taken too far. So yeah, unfortunately, I can't say one way or the other, just because I would need to look into it and kind of do a literary review to give you a good answer, just because I try to be really, really careful about confirming things that haven't been confirmed by multiple scientific instruments. Yeah, sorry about that.
No, actually, just sorry, I started talking and I realized I was muted. I think just your answer shows a lot that it's not because we hear one study about something on Mars that everybody takes that for granted, in a sense. Like, it needs to be verified and looked at differently, and people will need to look at, especially if most of us don't read the scientific paper directly, so we kind of look at different sources and see it. I mean, that's always good, like checking your facts and checking your sources. And sometimes studies, they mention there's a hypothesis about something, but then it needs to be confirmed by further study and so on. So I think your answer is actually very, very interesting for teachers to realize that you don't make stuff up and just go with, oh, I read that quickly, that's the truth, right?
Yeah.
Oh, here's another good question, and this is something we see, we talk about the future of science fiction. What about the concept of terraforming Mars? As you were searching for this webinar, what do you personally think about it? What did you read about it, and so on?
Yeah, so I think, as I said, if humans were going to go to Mars, like the risk of going humans to Mars, like pulling back to that question just for a second, humans wouldn't be able to pop up a farm and just grow potatoes on Mars. There's a little, yes, you're welcome for the reference. You wouldn't, there's going to be a lot of things that are going to need to happen. Maybe not on like a terraforming way that you might see in science fiction movies or in things like Star Wars or Star Trek. It's not going to be anything like that. Like, you can't put an atmosphere back on Mars. Like, something like that just isn't going to happen. You're not going to put liquid water back in the lake beds of Mars. Like, that's not going to happen. But in terms of small terraforming, like dome cities or dome farms, where you might have a couple of acres underneath a sealed container or a sealed tent that has a pumped in atmosphere, and you can use the soil there, and you're terraforming the soil to have more nutrients so that you can use it for farming in the future, and stuff like that. Like, yeah, I think that could be possible if it was possible to go to Mars. And again, we're waiting for SpaceX to tell us if that's the thing. But I think the other part of me is, if we can terraform Mars, we should probably terraform Earth, because we have a lot of especially climate catastrophes that have happened or that are coming up that are a little closer to home, pun intended. So I think small scale you could terraform Mars. I think large scale, that's getting into the things of like science fiction and magic, frankly. But anything is possible, and I'm not the spokesperson for every science field and what they're going to come out with in the next 10, 20, 50, 100 years. So maybe, but I'd say small scale for sure. And I'd say if we had anything that was like really big impact in terms of terraforming, we should help with our planet first.
Very good point. I was going to comment on that. I really like that point, and that's exactly what Ed mentioned in the chat, that it's a very good answer about, before thinking about making another planet livable, maybe we should take care of our own. Good point. I think that covers most of the questions that we had. I think most people are still online, so thanks for staying and listening to those questions. Last chance if you'd like to ask questions to Charles. But again, thanks a lot, Charles, for accepting to present this webinar and digging into all the information on Mars. There's a lot. It is definitely a fascinating planet, but it is a lot. I agree. There's so much, and there's so many. I like what you mentioned, that there's so many angles you can talk about Mars in your classroom. Just the cultural aspect of it is interesting. How to observe it in the sky now. Missions and what that means, and how should we send humans to Mars, and that there's a lot of ethical issues as well there. So that's very interesting, and how we can discuss it. Thanks a lot, everyone, for being there. I think we're at the end. I don't see, I'll give it another 10 seconds or so in case you're writing a long sentence. But thanks a lot, everyone, for joining us. Discover the Universe will have more programs and more webinars. There aren't any new webinars posted on our website, but there will be some in the future. Anyway, if you're registered, you will get our newsletter, so you'll know what's happening. Okay. Oh, I do have a question that came up. Could Earth become like Mars one day with the atmosphere gone?
So back in the day when I did planetarium shows at the Dunlap Institute, this was always what I ended with when we would leave Mars. I'd be like, Mars is our spooky future, like the ghost of Christmas future kind of deal. Yeah, which is horrifying, I know. So Earth's atmosphere does a lot just to protect the planet, to sustain the ecosystems that we have, and we kind of take it for granted. We definitely take, how important our atmosphere is in terms of, protecting us from cosmic rays, and even our magnetic field, which I did skip over with the Aurora. Our magnetic field does a lot to protect us too, and enable life to exist on Earth. If we were hit by a solar flare of similar magnitude and severity that what we expect happened to Mars, again, we don't know for sure if that was what happened, but if we did get hit with something like that and it blew away our atmosphere and messed up our magnetic field, yeah, barren wasteland, here we come. And that's really terrifying. So what you would expect to happen is that your water would get lost to space, so it would evaporate as per usual because of the temperatures that we experience here on Earth, and it would be lost to space because there's no atmosphere to trap it. We already lose some water to space and some molecules to space anyway, but not like what we would have if the atmosphere got blown away to the point where Mars is. And without water, that's it, game over. I know that's really dark. I'm sorry that we ended here, but yeah. So taking care of our atmosphere is really important, and definitely if we got hit with something like a really intense solar flare, and when I mean really intense, I mean like it wouldn't happen now. Like maybe in another few. When is the next really intense solar cycle? It's on the order of millions of years. Like it's going to be a long time before we have solar activity like that again.
And I guess
we don't have to worry about it, but yeah.
I guess the fact that the mass of Earth is like the gravity on Earth is quite a bit larger than gravity on Mars. That can also keep it. I understand the solar flare is pretty strong, but I'm guessing the gravity makes a difference as well.
The gravity does make a difference, yeah. So Earth could hold on to its atmosphere to some degree, but solar flares are, like, again, what we expect happened to Mars was really, really intense. And just a note here from another participant, you're right, we would be, oh, I don't understand what's happening here. Okay, you know what? It is true that our magnetic field is powered by the core of our planet. So it is definitely true that our magnetic field would be way more affected if Earth solidified. But it is, you know, any kind of intense solar flare or solar activity actually does affect our magnetic field on some level. And if we had a really intense solar flare, it might not stop, or, you know, it might not stop or seriously affect our magnetic field for a very long time, but it could disrupt it enough that there's a lot of damage done to the surface. Because keep in mind, we are also closer to the sun, and if there's cosmic rays and radiation, and we have, you know, fleshy animals like ourselves on the surface, so getting irradiated, it's not a fun time, even for short periods of time. So all those things together. But again, I think what this really emphasizes is that there's a lot of really cool science from a lot of different perspectives that you can look at this from. And so whether you're from like the physics and atmospheric side or chemistry or astrobiology, there's something here about Mars for everybody, even if it's just doomsday soothsaying like what I'm doing right now.
Yes. Okay. So I think we'll end here. Definitely a lot about Mars that you can include in your classroom, depending on all levels. Really, it's a very, 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 very topic. Not sure that makes sense. Yes. So again, thanks a lot, everyone, for joining. Thank you, Charles. I think we'll end here, and we'll see you in our next online program. So thanks again, Charles. If you want to say one last word, people can see you.
Yep, definitely feel free to make a copy of the Google Slides. Leave comments on any of the slides, especially if you want more information about anything. I'd be happy to provide that for you. Make copies of stuff, and we'll also send you the PowerPoint. But other than that, thank you so much for being here, and I hope you learned something.
Thanks, everyone. Bye-bye.